In your labs, for this particular section of the program, you're going to end up cutting and flaring 3/4 inch, 5/8 inch, 1/2 inch, 3/8 inch, 1/4 inch tubing. Cutting and flaring, then you will continue on with that size arrangement for a number of other labs. But what I wanted to talk about is one of your best friends in the copper business is a simple little Sharpie or felt tip pen. As a technician, you should have one of these in your pocket at all times. These things come in really handy. Your lab is going to tell you that you need to cut a piece of copper tubing 2 inches long. So here's your Sharpie in action. Make your mark at 2 inches. Don't forget to put the cap back on or it'll dry out. Then you're going to take your cutter, back it out so you can get it on this piece of pipe, and you're going to put your wheel right on the 2-inch mark. One of the criteria in the grading of this lab is going to be how accurate you cut your tubing. Go figure. 2 inches is 2 inches. Simple as that. Now, to cut the tubing, you put a little tension on the wheel and you can rotate it around just like this. Continue on. And each time you notice I'm cutting right on the 2-inch mark, okay? Each time you go around, you tension the cutter just a little bit more. One of the things about cutting pipe, if you're a super macho dude, you're going to use too much pressure on the cutting wheel. And what the result of that is going to be is you're going to roll the copper inside the pipe when you separate this pipe, and then you're going to have a lot of deburring to do. And deburring is something that comes next on the project. Okay, I'm almost through. There you are. I'm cut. Now, put this piece of copper tubing on the dock cam so we can zoom in and take a look at it. I'm not sure if you can see it well. What you have right here is you have a burr caused by the cutting wheel displacing the copper, and it'll leave a burr on the inside of the copper pipe. It also leaves a burr on the outside, which is not as noticeable. But here's what you do about that. That burr on the inside of the pipe is a restriction to flow. And one of the things you don't want to have on a refrigeration system in regards to the refrigerant flow through suction line, liquid line, any kind of tubing and piping that is in the system is a restriction to flow. The restriction to flow is going to cause a pressure drop, and if you have enough of these burrs on the inside of the pipe, you'll have a significant pressure drop. Of course, it depends on how many joints you have in the system and so on. But restriction to flow is bad news. Good manners dictates that you deburr the inside of every pipe that you cut. And what we're going to do is I'm going to demonstrate how to use this deburring tool initially. And I will say I'm not a fan of these type of deburring tools just because they're sort of awkward and I don't really think they do a good job. If you can see this, I'm just scraping this deburring tool around the inside of the pipe here and I'm deburring this. The reason I don't like this deburring tools is they don't seem to work very well, or at least they never have for me. My second best deburring tool, or actually one of my best deburring tools, is just a typical pocket knife. And yes, you have to sharpen your knife occasionally, but at the end of the day, a pocket knife does very well. And I'm just going to deburr this pipe. You can see that I'm getting a nice little curl of copper out of the inside of this pipe. Now that little curl of copper that you're deburring is bad news. The one thing you don't want to have is you don't want to have these kind of little curls of copper from your deburring process inside the system after you're all done. I'll tell you what will happen with this little piece of copper. It'll either get caught in a filter dryer, or a screen, perhaps in the entrance to the metering device, or worst case scenario, it's going to get hauled into the compressor. If it's a hermetic or semi-hermetic compressor, it'll get into the windings of that compressor because, as you might know, or maybe you don't know at this point in time, all the suction gas goes back to the compressor. And if it's a hermetic or semi-hermetic, the suction gas goes past the motor windings, which is actually one of the big ways that you cool that compressor down. And you have a little copper curl like this. What it'll do is it'll lodge in the windings, or between the windings, and the insulation on those motor windings is, I believe, somewhere around 1 to 2 thousandths of an inch thick. over time, with this little copper piece lodged in between a couple of wires on the motor winding, over time as that compressor motor heats up and opens, expands, and then you shut it off, it cools down and contracts. Over time, that expansion contraction action is going to cause this little copper thing to cut through the insulation of that motor winding. Once you have that happening, once it's in with the motor winding through the insulation, then you're going to have what is called a spot burn. You have a spot burn on the motor, and that spot burn will just continue to grow, and ultimately in a very short period of time you have just killed the compressor. Now, I'm going to continue to deburr this piece of pipe. It just takes a minute. If you're working with larger pipe, a good thing to use is a round file. But once again, remember that there's another copper curl. Remember that you don't want to leave any of the stuff inside the piping system. Once you get done deburring, you knock all that stuff out of there so that it does not contaminate the system. Okay, so now I've got the inside deburred. The next thing I'm going to do is I'm going to take a flat file and I'm going to deburr the outside of it. Now, this doesn't take much to do. It's just drag that file around the outside of this pipe and knock that little burr. There is a burr there. It's very tiny. But knock that little burr off the outside of the pipe. And I'll tell you why. Every time you do a piece of pipe, you do this exact same thing. You deburr the inside, you deburr the outside with a file. So you just knock that little burr off the outside. Remember, these cutting wheels, they're not actually cutting the copper. What they're doing is they're displacing the copper. And so what that means is you have displaced copper going to the inside of the pipe, displaced copper going to the outside of the pipe. The big deal about that little burr on the outside, and I can feel it right there with my thumb, I didn't hit it right, is the larger you have pipe, and maybe you're setting this pipe up for fittings, the larger you have this pipe, if you don't knock that burr off the outside of the pipe, if you can see this scenario, even 3/4 is starting to get really costly. I was in a hardware store the other day looking at some 3/4 water fittings, not refrigeration fittings, and they were gold. It was like six something a piece for a 3/4 inch 90. That's a lot of money. Now, as you can imagine, a water fitting is a short radius. A refrigeration fitting is always a long radius, and they're even more expensive than a short radius fitting. And the problem with this burr on the outside, what I'm getting to here, is that the larger the pipe, if you do not prepare the pipe correctly by deburring the inside and the outside, you put that fitting on there and it might be stuck for the rest of your life. You might not be able to get that fitting back off. It might not slide on all the way. There's all kinds of issues with not deburring the outside of the pipe. And as you get into larger pipe, the fittings get more and more expensive. How many of you guys are going to want to write off a $15, $20 fitting just because you didn't do the job right? The last thing you do to prepare your piece of copper is a piece of sand cloth you have in the lab there or at the job site, and you polish this thing up. That's pretty easy. What you're doing here in this polishing is you're cleaning the copper off to accept a fitting, which you're then going to braze or solder. Notice nice, clean, shined up copper. Notice the difference here. This is what you call oxidized copper. This is what you call nice, shiny, clean copper, ready to take your brazing or soldering material. Got to clean the pipe.